Dad, I'm recording you right now, so everybody be good. Alright, here we go. So slideshow here, begin from this current slide. There we go. Okay, go ahead and, number 8, go ahead and graph 3x equals 4y. Alright, your tests here. I'll bring those around to you. Okay, and you're done looking at them, you will begin those back. Now, I got to mention one thing right up here. As you start learning more conics, you learn how to graph circles, you learn how to graph ellipses, hyperbolas. The one thing you got to know is when you look at an equation, it'll always be a parabola if there's only one squared term. And that one squared term is the one that should be isolated by itself, okay, on the other side. So in other words, if you're going to write this down into vertex form, okay, do you guys see how I isolated the x by itself? I could have wrote it like I did right there in the circled parts, okay, but I wanted you to be able to realize I can put that, okay, in its correct form first. Okay, then from there, go ahead and find your focus, okay, your directrix. Okay, whatever it is that you now need to find. I asked for 3% for you, so you can do that and add 3% in there. So I put it in the gradebook. Yeah, the gradebook I got lazy this time, and I added the 3% automatically into your scorebook. So what's in PowerSchool right now already includes 3%. That's in there. All right, let's take a look here. What did we come up with? Check your neighbor first. That's all right. So check with your neighbor, see if they agree or disagree with you. And then you yeah, so then you take 4C times that, you get 16 over 3C, and then you take the other side. It should be 6%. Your answer. Right, so checking this one out. Okay, so as I look at this one right here, I got, like I said, x equals right over here. I then had to find the focus, okay, which I set the 1 over 4c equal to the 4/3 cross multiplied. This one's a hard one to graph, and because that's only going to be 3/16, but since it's an x equal, we know that the directrix is also an x equal, and the x equal is going to be from the vertex, which we said on the last slide was 0, 0. Okay, left is going to be negative 3/16, but the directrix is not a point. It is going to be a line that has an equation, x equals negative 3/16. And the focus then goes 1 unit, or the c value, to the right, which is then 3/16 to the right. Okay, and is everybody okay with how I try to draw those little lines that are in there? This one I'm not going to worry about so much for you guys. Okay, but the main thing we're doing again is every point is equal distance from the focus to the directrix line. Okay, and this would be a really skinny one. Okay. All right. Rotate to your left. Make sure everything's out of your way so we don't trip over it. Just bring your test with you so that I can pick that up from you. I'll hand out your district assessment test here in a little bit too, so you can see that score. This one I did, okay, just to see how much you retained without extra practice like I did before. So this wasn't as high a scores as you did the first one, but overall you guys still did a really good job. Okay, this is the hard part, knowing which way your left is. 1 to the left. Yep. All right, here we go. Next question, number 9. Okay, go ahead and graph. Okay, that right there. Yeah, you may be running out of graph paper. If you do, just sketch them on the front and the bottom or something like that. I think there's a little bit of space at the bottom on the front. Yeah, just draw an X and Y axis in the front. I will, yeah. I'll come around and get both of them as I... Everybody in here get their district assessment test back? Alright, let's take a look right over here. Again, get that y by itself. Okay, so you're going to have to divide. Does this 4 divide into the x plus 2? Okay, we know it just goes into the 12. Okay, right here. So I did do that, okay, to make my equation right there in vertex form. So I got a vertex, okay, of -2, 0, because as I've always done, set that equal to 0. Okay, set the 3 equal to 1 over 4c. You got c is to be 1/12. So that means that since this is a vertical graph, from the vertex, I had to add 1/12 up from the vertex. That's how I got the focus. And I had to subtract 1/12 from the vertex's y-coordinates. This is not a coordinate down here, but that's just the equation of a horizontal line. Okay, and that is really an ugly graph over there. Okay, but there is my sketch. Okay, all right. Go ahead and give your points. You both got it right. Okay, didn't get it right. Like we were doing yesterday, I forgot to tell you that last round. Total them all up. Remember, the points don't mean anything. They're just for me and you to see how you've been doing each round, if you've been progressing. All right, rotate on. Oh, God. We have to keep those. Everybody got both tests, your Chapter 8 test and the district? All right, check with your partner, see what they came up with.
But I have it written down.
I'm probably wrong.
All right, here we go. Okay, what should we have had? Well, I got on this one right here. You had to set the single variable, Okay, so the one that has a power of 1, okay, by itself. So I got the 24 the other side, but then I had to divide by negative 24 so that you had this as 1x. So now I know it's a left-right graph because it's x equals. Directrix is also going to be an x equal. So I set this negative 1/24 equal to 1 over 4c, and I see that my c value is negative 6. So immediately that tells me it goes to the left since c is going to find the focus to the left. So I took my vertex, okay, which I knew my vertex on this one, if I wanted to put it in the correct form right here, would have been x equals negative 1/24 y minus 0 quantity squared plus 0 like that. My vertex is at 0, 0. Okay, so this immediately says, okay, take and subtract 6 from the x coordinate. So I subtract 6 from the x coordinate. That found my focus. Okay, and then I'm going to add 6 to the x coordinate, and that found out my directrix equation, not a point, but the equation. Okay, and then you can see I did a much better job on this one, knowing where my vertex was. Okay, right here at 0, 0, down and over, okay, the same amounts, and got my graph. Questions are on that number 10. Right. So are we doing better than we were at the beginning of yesterday?
Yes.
Except for those of you that were gone yesterday. Obviously you're picking up. I told you the pieces would come together. Okay, but the bad part about this chapter is this stuff right here, once I start talking about circles, I talk about ellipses, don't forget about focus. Doing the focus and the 1 over 4c steps. Okay, rotate on for the last one. Check with your neighbor next to you, see what they came up with. All right, let's take a look. See what you guys came up with. Now, this one took a couple steps in order to go about getting the y isolated by itself. I chose to bring the y over to the right side and then move the 32 over to the left side, then divide by 8, okay, which put it into vertex form. And that allowed me right away to set the x equal to 0, x plus 1 equal to 0. Okay, that found my vertex. Okay, I then found my c value by setting 1 over 4c equal to 1 over 8. Okay, and I got my c as 2. Okay, and since this right here is a y equals graph, that means the focus is going to go vertically, a positive 2. So vertically, okay, from the vertex, I add 2 to it, and negative 4 plus 2 is at a focus of negative 1, 2. Okay, so there's where I had my focus right there. Here's where I had my vertex right there. I go backwards, okay, to find my directrix, and that directrix is an equation. And then I went up there and I graphed it, and I found my answer. Okay? All right. Scale of 1 to 5. How are we doing here on parabolas now? Okay. This one's not in the slideshow here, but I want to do something here first. So go ahead and add this to, you can grab it, add it to your notes here, or you can put it in on that sheet of paper. I don't care where you do this. But all I want you to do right now is tell me where the vertex and the focus, okay, where are they at for this equation? Why is this one different? I got some puzzle looks out there. It's in a different form. So you had two options when you did this one right here. Then you have one option was completing the square, or the other option is find a line of symmetry using negative b over 2a. I'm actually going to use completing the square because that rolls into my next lesson. But in this problem, I didn't care, okay, which way you did this. Okay, and okay, remember completing the square, how we grouped those two together right there? Okay, and then we came up here and we have the x squared plus 6x. Okay, put the 1 out here. Okay, what do we do to this 6 right here? Okay, found half of that and squared it. Okay, that amount here now comes to this right here. That is now a perfect square. And that was the whole point of why I completed the square, is because now in my vertex form, okay, I have the h coordinate for the vertex is 1, the y coordinate for the vertex.
No, you
Okay, so that's where I said, okay, if I added 9 right here, I have to, well, I could add it over here, but is that going to make your equation look like you want it in vertex form? Then you just come over here and subtract it there and subtract it here, and we end up getting here minus 8 instead. So my vertex, okay, on this right here is at, -3, -8. I'm hoping you're good with me, not setting that equal to 0. Okay, focus. Okay, my focus is found by taking the A value, okay, which is 1, and setting it equal to now 1 over 4c. Put that over 1, we get 4c equals 1. Divide by 4, and my c value is 1/4. Am I going to add, because it's a positive, am I going to add to the, I'm not graphing it, I just asked for the focus. So do I have the vertex go above, or sorry, the focus above the vertex or to the right of the vertex? So that means I'm going to add to the y coordinate or add to the x coordinate? Okay, so I have to add 1/4, okay, higher than -3, -8, okay, which gives me a coordinate of -3, comma, -7 and 3/4. Did everybody follow me on those? Yes. How would you? Okay, you still are going to end up putting it into this form right here. Okay, the negative b over 2a is going to find out, oh yeah, here's my line of symmetry, which my line of symmetry, I would have had at -3, right? Isn't that what you got? Then you would have said, okay, well I have to set this equal to 0, so that's my coordinate right there. And then I got to plug this value back into this equation right here to find my y value that goes right there. Does that make sense? Okay. All right. So, got a choice for you guys. You guys can watch the video lesson, or I can just do the quick video lesson here in class and get it done with for you. In class? Okay. It shouldn't take you very long. I'll just quickly go through it. It was a short one. Okay, so go ahead and go back to your desk so you get your notes. Okay, and I'll pull up the video lesson here. Okay, of what I wanted to do. Now this is on to our next product section. No, we're going to go to the next easiest one that you guys have already learned a little bit about too. And circles you learned. So that's why it's an easy one, because I'm hoping, okay, you've had circles so far. All right, circles. Okay, so what we have to learn first is, where does the circle equation come from? Okay, the circle equation actually comes from, okay, drawing a right triangle and calculating the length of this radius. Because we need to know how long this radius is in order to calculate the equation of a circle. Okay, well I did that to calculate the length of this radius. What type of shape did I draw right here?
Right triangle.
Okay, and the last time I knew right triangles, okay, you could use the a squared plus b squared equals c squared. Okay, so that's what I did right here. But instead of me just saying, oh yeah, the circle equation is a squared plus b squared equals, because that really is the circle equation. Okay, I know, it's a right triangle, that's there. The only thing they have is, we have to use the h and the k to talk about, well, that's our center. Okay, our h is going to be our x coordinate center. The k is going to be our y coordinate center. And the distance, you guys remember me teaching you or showing you how to know the distance formula? Well, I'm going to take this coordinate and that coordinate right there and use that to find r, which is that part right there. So before I do that, I took this and I square rooted it, okay, right here, and to find r, which was my a squared, okay, I did x minus x minus x, and for the y, I did y minus y, which is y minus k. And since this was r squared here that we were trying to find, I square rooted it, and this right here came up with the circle equation right there. Okay? Now, we're going to, instead of using square roots, okay, we're going to take this length right here, and we're going to write it the way we originally had it, because I don't want the square, I'm going to avoid square roots if I can. So I'm going to square this side and square this side, and here is your formula that you're going to come up with for circles where h comma k, that is now not considered your vertex, because we don't have a vertex on a circle, but it's the center, okay, and r is the radius. Okay, so there is your new formula that I just showed you. Okay, notice that on circles, there's how many squared terms? 2, one here and one here. Okay, this part right here is always going to be squared, but you know it'll be a number. Okay, because it'll be like a 5 squared there. Okay, I'll show you here in a little bit. Okay, what that is. Okay, whereas when we talked about parabolas, there was only one square. Okay, so as I come up here and graph this, if I have this problem right here, okay, my center, okay, is going to be located at, set that equal to 0, set the y equal to 0. So I have, okay, go over 3, down 2. Okay, there's my center. I'll label it 3, negative 2. Okay, I'm going to come up here and I'm going to say, okay, well, this equals r squared right here. So I have r squared equals 25. Do the square root. Now the radius is plus and minus 5, but can you have a length of a radius that's negative 5? Okay, so because I put the square root in there, I knew that had to be a plus and minus. So if you're asked to graph this, okay, some of you would just come out here and graph something that's pretty ugly. Okay, and others would say, well, I'm going to go up 1, 2, 3, 4, 5. There's a point. 1, 2, 3, 4, 5. There's another point. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now at least I have some reference points to try to make, okay, my circle look a little bit better. Does everybody understand how I made my circle, how I expect it? You draw the 4 points around, okay, and label them from there, yes.
So it's in like the right form, so like the 25 is the r squared, but did you write center 3, negative 2 next to r squared, or did you just do that?
No, this was, I was trying to do it right there underneath it. That wasn't supposed to look like it was in red. Okay. Alright, so, okay, coming up here and graphing this one right here, again, okay, tell your neighbor next to you right now, where is the center going to be located? Okay, so we have 3, negative 5, so I'm over here at 3, down 5. Okay, label that, 3, negative 5. Tell your neighbor next to you, okay, what's the length of the radius going to be? Okay, so when I graph it over here, I'm probably going to want to know the decimal. But when I ask you the radius length, I need the exact length. So the exact length was the square root of 72, but that simplifies square root of 9 times the square root of 8. Or you should have noticed, if you did that, is that all the way simplified? Because this is now 3 times the square root of 4 times the square root of 2, which is 3 times 2 times the square root of 2. This is a lot of work, okay, right here, when you could have said this was the square root of 36 times the square root of 2, which is 6 square root of 2. Okay, but still, if I was to come over here and graph 6 square root of 2, how many of you guys are going to know how much 6 square root of 2 is off the top of your head? Okay, right, but this is what I want written down for your radius length. Yes, we're videotaping right now. You want to come teach so you... No? Okay. Okay, let me finish this. I'll be right there, okay? All right, so I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more. Okay, 1, 2, 3, 4. Yeah, I got you. And 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more. 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more. 1, 2, 3, 4, 5, 6, 7, 8, and a little bit more. There we go. You guys see how when I sketched it, okay, I just wanted a quick sketch. But when I wanted the accuracy, I kept it here with the accurate, not decimal answer, because the square root of 72 doesn't go out to, 7, or like 8 point, it's irrational. Okay, so I'm going to keep it as exact as possible. All right, scale 1 to 5, how are you doing here so far? All right. These are going to be better in parabolas, okay, but there's usually a little bit of a trick to this sometimes. Sometimes the equations start getting a little uglier looking. Okay, they always start off pretty. You look at things and you're like, oh, this is a piece of cake. I set you up. You're right, but that's part of teaching. You get you feeling confident, and then you got to throw something in there that challenges you, and then you build your confidence back up. This is not that bad though. What do you notice about this quadratic right here? See, if I was really mean, I wouldn't have put parentheses around it. Okay, and you get what I'm saying? I just would have started putting a whole bunch of numbers in there, and you would have had to organize it all. Okay, but right now you see that, oh yeah, this part right here, okay, is, oh yeah, x minus 1 times x minus 1. Oh, there you go, I got that one. This one right over here is y plus 5 times y plus 5. Okay, so, all right, now I see that there's 2 squared terms. Okay, there were 2 squared terms before. So we knew it was a circle, not a parabola. Okay, when you first looked at it, you thought, well, what's this thing going to turn out to? But now it's a circle again with a radius that's the square root of 48. So our center is at 1 comma negative 5. And our radius on this one, if you find the biggest perfect square, okay, yes, you could have put 4 into that and got 12 and the square root of 4, but then you would have broke it down again. So our radius is 4 squared to 3. If you were actually to graph that, the square root of 48 is just shy of 7. Square root of 7, so square root of 49, sorry. So that's what I would have done if I had to graph. But right now I didn't ask you to graph. Just find the center and the radius. All right. Scale 1 to 5, how do we do right there on that one then? All right. So hopefully I didn't kill a finger. Solve this one. Find the center and find the radius. Okay.
I know it is.
All right, so this one right here, hey, this y, if you don't like it just being like that, there you go, put it as y minus 0. Okay, so we got that. This part right over here now, we're going to do the completing the square. Because this part right here would tell us that if we did that, we'd have x squared plus 6x plus 9. Is this right here a perfect square? I believe it is. It's x plus 3, the quantity squared. So we found our center. That was pretty neat. Negative 3, well, for some of this is cool. And is our radius 4? You're right. Apparently not. I'm trying to allude to you that you screwed up. Because you just made the left side of an equal sign. This side of the equation right here, you just made 9 bigger. Are you going to come over here and subtract 9 right outside of it? No. Does that help your equation out by, you could, I mean, that's balancing it. But how about we bring this over here to this side, and what do we have to do if we bring it over to this side? Yeah, we can add it here, and maybe that helps us out, because now we have 25 there, and our radius, okay, is not, and be careful, if I get numbers like 4 and 9 here, I can see some of you saying the radius is 4, or the radius is 9. Remember, it's r squared equals, okay, 25, so the radius looks like, did I do that right? 5? Yes. What's that? Why didn't I subtract 9 in here? Okay. Well, if I subtract 9 in here, I can do that. Okay, but how's that going to help my equation out? Is that in standard form? No. Then I just move it right over here and I add 9 over there. Okay, but yeah, you could have left it right outside that, like that, but then I'd just come up here and say, oh yeah, let's add 9 here, so that cancels, and let's add 9 over here. Oh yeah, that's okay. Does everybody understand what standard form looks like for a circle? Yeah. All right. Okay, go ahead and find the center for that last one. Yeah, we're having really lots and lots of fun doing these things. We're having lots and lots of fun. If we're not, we're kidding ourselves. We're having lots and lots of fun. What else would we rather do than have more fun in the class? This is part of what we're going to be doing on Monday, so don't freak out when you see the size. I'm just giving it to you now so you get started on it.
You better have this done by tomorrow.
No. Maybe the front page. Have done. Yeah. Oh, that's a good question. I like those. All right, so this is one that I kind of shuffle things up. Okay, and what I would do here is I would put the x terms together. Okay, I would put the y terms together. And where is this 3 going to go?
Oh, tell us.
Yeah, why don't we put it with the radius, okay, right over here. Okay, so now we have it, you know, kind of like we did on that last problem. Okay, so I come over here, and I want to find half of 4. Oh, that's 2 and square it. I want to find half of 6. That's -3 and square it. Okay, so right here I have x squared plus, remember you don't actually do half of it, you just do half of it so you know what to square. This is x plus 2, the quantity squared. Okay, this is y squared minus 6y plus 9. And this is now y minus 3, the quantity squared. So you got a center of -2, 3, and a radius that's the square root of 3. Why not, Zelda? What's wrong?
Didn't add to the others.
Okay. This part right here, when we come up here and we add 4 immediately. Okay, come over here and put plus 4 here. We add 9 there right away. Once you put that plus 9 from this, don't, because that's what's commonly forgotten. Balance the equations out. So now it's not 3 here, okay, but 3 plus 4 is 7, 16.
Yeah,
right?
that's what I got.
Okay, so I have a center. The center didn't change. Most of you, when you do that, you'll get the center right. Okay, but the radius, okay, is the square root of 16. Okay, which you guys. All right, tell your neighbor, okay, 1 or 2 things that we talked about this lesson. 1 of them or 2 of them that you got to watch out for as you talk about today's
Mr. Johnson. Mr. Johnson. That is now like a little language. Don't be scared. Swear.
Sounds like a rhythmic or a limerick or
I think that's what they're called. We're math people. We don't.
yeah, exactly.
Oh my god, I can't say don't be scared. Everything sucks.
Alright, this may or may not be obvious, but I wanted to make sure I pointed out. If I was to graph this circle right here, and there's my center, it's obviously going to be at 0, 0. How would I know if 2, 3 is on the circle or not? Plug it in, okay? Is 2 squared plus 3 squared, is that equal to 13? 4 plus 9 equals 13. So that's the equation of the circle I was talking about right here. Okay, I'm asking is that right there on that equation, is this one going to be on the circumference? Well, how about 1, negative 4? Okay, if I go over 1, down 4, do you think that point right there, okay, 1, negative 4 is on it? Okay, that right there would be 1 squared plus negative 4 squared. Does that equal 13? Okay, I believe that equals 16 or 17. Okay, so this one is not on it, okay, and this one is on it. Okay, that's one last thing that I had, to talk about it. Okay, there won't be a quiz here because I did it in class. Okay, but the worksheet that we have right here, okay, do as many of them as you see possible. We'll finish this on Monday. Okay, so at least maybe the front that's there. You can kind of see everything else that we're going to tackle. You want to after that. I don't care how many of you do. Okay, but I'm gonna have a little bit of some stuff on Monday, but then we're just a work day.
So is
No. Lexi had a question. Okay, let's go back here to this. And I'll let you ask your question. Okay? Your question was what? How do you do the inequality? Okay, so here we go. I'm going to put a greater than or equal to sign right here. How do you shade something that's greater than or equal to it? Okay, so if it's on the outside. What happens if I don't have that equal to sign and I just have it as a greater than sign? Okay, so there you go. So there you go. So I have just talked to greater than or equal to or less than or equal to. Yep.
Mr.
There you go.
How do you figure out if it's on the line? Is that x squared plus y squared equals 3?
That if you figure if it's on the line, that was this last part that I did right here. Okay, plug it in the equation. Right there.
So they picking only is x squared plus y squared.
Well, the equation is x minus h plus y minus
so you're
k
plugging in the x and y.
equals r. The center's at 0, 0. You plug in the h in there, and then you plug in what the radius is, and then you find if it's on there. Okay? Yes. I need your tests back here, so go ahead and get those. Let me hit pause here. Everybody say goodbye to their friends.